welcome back to our channel Nexel Electronics. Have you ever found yourself standing at a bus stop, constantly craning your neck, wondering if that approaching vehicle is your bus or not? Or perhaps you are in a busy area and it's tough to distinguish between different routes. That uncertainty can be a real pain. Today, we are tackling this common frustration with an existing project, that is an RFID-based automated bus stop announcement system. This isn't about announcements inside the bus, it's about making bus stops smarter, safer, and far more informative for everyone waiting. So, how does this smart bus stop actually work? The core principle is simple but powerful. We are using RFID, radio frequency identification, to create a digital handshake between the bus and the bus stop. Here is the magic. Each bus will have a small unique RFID tag affixed to its underside or side. At our bus stop, we will have our RFID reader module. As a bus approaches the stop, its unique RFID tag enters the range of our reader. Once the tag is detected, the reader at the bus stop instantly identifies which bus it is, perhaps its route number and destination. This unique ID then triggers our system to play a pre-recorded audio announcement like bus route 100 to Secunderabad station approaching. It's about providing real-time automated information to those who waiting, eliminating guesswork and anxiety. Let's break down the components that bring this intelligent bus stop to life. Arduino Uno. Our reliable microcontroller will be the heart of the bus stop unit. It constantly listens for RFID signals, processes the detected tags, and then commands our voice module to play the correct announcements. The Arduino's versatility and vast community support make it ideal for prototyping such systems. The Listener RC522 RFID Radar Module. This module is our primary sensor, tasked with detecting the RFID tags on the approaching buses. It operates at 13.56 MHz and communicates with the Arduino via SPI communication. While the RC522 is excellent for learning and prototyping due to its low cost and easy to use, its typical read range is only a few centimeters. For a robust real-world bus stop system, you would likely need a more powerful ultra-high frequency RFID reader, which can read tags from several meters away. However, for our demonstration, the RC522 allows us to clearly illustrate the core concept and logic by having our bus pass very close to the reader. The Voice APR3600 Voice Module. This dedicated module stores and plays our audio announcements. It's simple to use. You record your messages on it, and then our Arduino sends a digital signal to trigger the correct announcements segment. It provides clear audio output for our speaker. The Speaker. A small weather-resistant speaker connected to the APR3600 will ensure the announcements are audible to passengers at the bus stop. RFID tags. These are the unique identifiers we'll attach to each bus. We'll use standard classic 1K tags or key fobs for our demo, which are robust enough for attachment to a model bus. Now let's put it all together. This unit will permanently install at the bus stop. Arduino and RC522 RFID reader. Connect the RC522's VCC to the Arduino's 3.3 volts and ground to the Arduino's ground. The SPI communication pins are crucial. SDA to Arduino digital pin 10, SCK to pin 13, MOSI to pin 11 and MISO to pin 12. The reset pin goes to Arduino digital pin 9. Again, double check these pins against your specific RC522 module's documentation. Connect the VCC of the APR3600 to Arduino's 5 volts and ground to Arduino's ground. We'll use Arduino's digital output pins to trigger the APR3600's various audio segments. For example, connect Arduino digital pin 2 to APR3600's T1, pin 3 to T2 and so on. When the Arduino sends a high signal to T1, it plays the first recorded message. APR3600 and speaker. Connect the speaker's two wires to speaker plus and minus terminals to APR3600 module. Before our system can speak, we need to record the actual announcements onto the APR3600 module. These will be bus specific messages for the waiting passengers. Power up. Connect the APR3600 to a stable 5 volts power supply. Recording. Most APR3600 modules have small microphone and record buttons on it. For segment 1, we might record attention bus route number 100 to Secunderabad station approaching. For segment approaching now, bus route 200 to Paradise Signal. For segment 3, bus route number 300 to LB Nagar is arriving. Tips for clear recording. Speak slowly, clearly and maintain a constant volume. Release and test. Release the record button when done. You can test and playback by pressing the corresponding play button. Once recorded, these audio segments are stored on the module's internal memory, ready to be triggered by Arduino once a bus is detected. Now for the intelligence behind our smart bus stop, that is the Arduino code. We'll start by including the mfrc522.h library to handle communication with our RFID reader. In the setup function, we will initialize the serial monitor for debugging the RFID reader itself and importantly, set up our digital pins connected to the APR3600's trigger inputs as outputs. The main logic resides in our loop function, which continuously scans for an RFID tag. In our loop, we first check up for and read any new RFID tags. Once a tag's UID is obtained, we compare it against our pre-programmed list of bus UIDs. The crucial part here is the debounce logic. This prevents the system for spamming the same announcement every millisecond as a bus stays in range. It ensures that the bus route number 100 is announced only once per detection event or after a certain cooldown period if the bus remains stationary near the reader. Alright, enough theory. Let's see our smart bus stop unit in action. Here is our prototype, the bus stop unit with its RFID reader and our bus model with its unique RFID tag. As our bus route number 100 model approaches and its tag enters the range of RFID reader, then you can listen the voice of
Attention, bus route 100 to Secunderabad station approaching.
Fantastic. The first announcement is clear and precise. Now let's try with bus route number 200.
Approaching now, bus route 200 to Paradise Circle.
Perfect again. This system provides real-time, helpful information directly to the waiting passengers. Imagine this in a real-world scenario. No more guessing games at the bus stop. The benefits of the systems are immense. Reducing passenger anxiety, improving accessibility for visually impaired individuals, and simply making public transport more user-friendly and modern. However, for real-world deployment, these are challenges. As mentioned, the RC522's range is very limited, means a powerful radar like UHF RFID system would be essential. Environmental factors like rain, dust, and temperature variations need robust housing. Power supply for an outdoor unit would likely involve solar panels or a reliable mains connection. But these challenges pave the way for exciting enhancements. You could add a large LED display to show the route number and destination visually. Integrated it with the real-time bus tracking system via a Wi-Fi or GSM. Add solar panels for self-sufficiency or even incorporate multi-language announcements for diverse communities. The potential for intelligent urban infrastructure is vast. So that's our RFID based automated bus stop announcement system. It's a prime example of how simple accessible technology like Arduino and RFID can solve real world problems and improve daily life. We hope this detailed walkthrough inspires you to experiment, build and innovate. Whether you are a student, a hobbyist or just curious, diving into projects like this incredibly rewarding. If you enjoyed this video and found it helpful, please give it a thumbs up, share it with anyone who might find it interesting, and most importantly, subscribe to our channel for more exciting tech bits and tutorials. We love hearing your thoughts, so drop your questions and ideas in the comments below. Thanks for watching and we'll see you in the next project.